during the code. Okay, now the not so great things about it, because everything has some not so great things. The documentation is pretty good in the 80% cases. In the 20% cases, it's pretty rubbish to non-existent, and you're on your own kind of thing. There does seem to be a fair amount of help. The IRC channel for Android development has a few of the Android developers on there, and they do seem to answer questions, so you are able to get help from people who know kind of thing. But there's a lot of edge case stuff that isn't documented or is very poorly documented. Device availability, as people have asked me before, does this roam in New Zealand? Yes, the answer is yes, it does roam in New Zealand, but because it's my customer's phone, not my phone, and they're not prepared to pay their data charges for roaming in New Zealand, it's turned off, which you can do, which is nice. You don't just automatically get it. But getting hold of devices has been difficult. We've got one here, and they've got a couple in the US, the people that we're dealing with, but they're not easy to get hold of at the moment. This is going to change, of course, with more people bringing them out. No help system. I was amazed. We were doing an app. We wanted to do some in that help stuff. Just Series 60 has some nice sort of pop-up screens. You can say, "Here you go. Here's the help for the thing you're currently doing." There's nothing in Android at all for it. No help system designed, done, or anything. It's kind of odd, I thought. There's no updating system for updating software on the your software on the phone. There's updating for Android software, and it happens really well and totally seamlessly. I've had it do 4 or 5 updates because they've broken the jailbreak hacks and the reboot hack and a few other hacks that they've had for it. Did everybody follow the reboot hack? It was brilliant. Apparently, under the hood, it runs Linux under the hood, by the way. There was a root console app that was running with a shell open that was capturing every single command you typed in. And so you could just type reboot and enter anywhere in the app and it would reboot your phone immediately at that point. So they've since closed that off. It's apparently a leftover bit of debug code, but yeah. Not so great. Yeah, possibly not so good because apparently once you remove the device drivers you're buggered. You can't flash it from hardware. You need to take it back to them. The error handling is not great on it. There is one error state on the device, and that is your app has done something bad. You're forced to close it. That's it. Goodbye. It doesn't matter what it is. That's all you get back, which is not really all that useful when your users ring you up and say, "App doesn't work. It crashes," and you're like, okay, well send me a device and I'll debug what's going wrong. You know, there's a few common error states that you get into. There's a permissions model in the devices. So when you want to do things like make a phone call, open a web browser, look at the GPS, that kind of stuff that is either going to use power or use money for the users on the device, they require you to request those permissions so that when the person installs the app, it says, look, I use the following things. You can see that in the list of things the application does. Pretty standard phone software model. The emulator supports everything by default without any permissions model required. So you can run stuff in the emulator and it goes, I run beautifully, I'll make phone calls, I'll do this, and you forget to put them in your manifest file, and then you launch the app and the user goes, it crashes. And you're like, it would have been nice if you just said, you know, you didn't have the permissions to do that, or use something else. You know, you see users going, oh yeah, the app just crashes badly at some point. Another problem.
Have you written a patch?
No. No, I have not written a patch. I haven't actually even looked at what it does. More important things to do. Sensor emulation. There's a whole lot of sensors on the device for cool things like doing rotation sensing, compass, accelerometer, so you can shake the phone and do things much like everybody's seen on the iPhone demonstrations. There's no emulation for it in the emulator, so if you want to test your apps, you need a real device. There is no way to do anything else, which is a bit of a pain in the ass, given that they're hard to come by. And finally, the naming conventions and application structure. As I mentioned before, they called views, activities, and components views, and there's a few other things that they've done like that. It's not, you know, terrible, and you can learn to live with it, but it could have been done better, you know, if people had just followed a bit more standard approach that other people have done in the past. All right, so let's have a look at some code. No, let's not do that. How do I stop the slides through? For those of you who are NetBeans or what's the other one? IntelliJ users, I don't know what's available in the way of that. Google themselves released the Eclipse plugin for Android. It's really good. Everything just works in it. But everything is doable. Everything the plugin does is just calls to their command line tools. So presumably you could easily write one for either of those IDEs.
Is anybody using JoJo app?
Yep.
Mm-hmm.
Okie dokie.
So from 7 up to 6.
7's so much slower. It is very slow.
Okay, so no, let's not do that.
You always work at 640 by 480?
I do when it's on the giant big screen. It doesn't give me any other option. It just randomly changes mine to whatever it thinks it can do. So this is what I get.
Have you tried changing it up?
No. The last time we did this at
It's not.
the Jet conference, it was not a good look. So let's not do that.
Well, have you succeeded?
Okay, let's make it a bit bigger.
Didn't notice my machine reduce, so
It was. I just couldn't get it to run. When I plugged it into my laptop, it decided that it wanted to be in 640 by 480, and that was the end of it. There was no discussion at any time we tried to adjust it up. It said, no, you're not going to display any image.
well, the blind people at the back actually appreciate it.
Yeah,
we like it.
Yeah.
That's all good. Okay, so
That's why I'm up front.
we'll cover the resources first. So the resources there are drawables, which are your graphics. There are layouts, which are your screen layouts. There are values, which contain your beautiful blobs of arrays that you want to have statically embedded in your program, and all the strings for internationalization. And there's a generic XML branch which has our preferences in it for some reason. I'm not quite sure what that is like. Let's have a look at the main screen. Okay, so they give you a kind of drag somewhere here. This is drag that across.
Is this your customer's app?
This is our customer's app. Yep. So the people we've done this for are called GeoVector. A real brief rundown on the app so you understand what it does. Basically, they do location-based directional search. So you have your phone with a compass in it. You point in a direction, and it will tell you what's in that direction, kind of thing. So that's. And then from there it links to all sorts of stuff that it can find about the information that it finds in that direction. So you say, I go in this direction, it says there's a Sky Tower over there, and then it'll give you the wiki link to Sky Tower, the Flickr link, the YouTube link, and tons of other stuff. Yeah, so this is what you get from their layout engine. You can sort of plonk components on the form in XML and then see what they look like. So you write it by plugging XML in here that tells you what it's going to look like. You can see it's pretty straightforward. You say I have, for example here, it's telling you it's drawing a divider on the screen, source for an image view, and somewhere down here I'll find you a text view here. So the ID identifies it for use later in the thing, set a text. They have a concept of gravity, which is where the components will levitate towards. So if you have gravity center, obviously it will drop to the center of the screen, left, right, up, down, kind of all the sort of standard stuff. Then they have, on top of that, they have what they call a relative layout, which lets you say, okay, and I want to tether these to other components, kind of thing. So all the usual standard stuff that you get everywhere.
All screens won't be the same size.
All device screens will not be the same size, absolutely not. There's a minimum specification, I think, of quarter VGA for them, but things are coming out with half VGA. That's a half VGA screen already, so it'll probably get worse rather than better before they come up with a new standard for that. Okie dokie, so various bits and pieces, nothing too interesting there, and you can see, of course, with their layout, that it ends up looking something like this. Now, as I said before, this compiles, when you compile it, someone here, I'll drag this over a little bit more, you get an R class out of it at the end. So all of those, if we scroll down to somewhere, see ID, if we go back to main, and flick over to the XML. Okay, so this bottom bit here, right at the very bottom of the screen, it displays the compass, which just tells you what direction you're currently pointing. And you see it's got this weird sort of syntax here at the start of the name. You don't have to put that syntax in there, but that at plus ID syntax says, when the resource compiler finds this class, grab the name that follows this and stick it in R class under the subclass of IDs. So if we drop back to the R class, you'll see that there's a public static final class ID, and somewhere in here you'll see there's a static for compass display. The way you find components in Android, all the activities have a find by ID method, and you pass these IDs to them. That gives you the components, so you can interact with them, do whatever you like, kind of stuff. So very straightforward.